All right, so now we get to the interesting part. Now we're going to look at ones that aren't just regular theta. Actually, let's do this. You know what? No, I'm just going to start this all over. We're going to do 2 cosine. Oh my goodness. Cosine of 2 theta. So this will be the first time we're seeing something where it's not just a regular theta. And if you think back to pre-calculus, anytime we had this type of graph, that coefficient of x or theta, whatever it might be, would affect our period. And we use this form 2 pi over b, and in this case our b is 2. So we would actually get a period of 2 pi over 2, which equals pi. And how is that useful to us? Well, normally we just look at these 4 main guys, pi over 2, pi, 3 pi over 2, 2 pi. Whenever the period shifts, and it's not just from 0 to 2 pi anymore, we now have to look at new intervals, right? So we take whatever this new period is and we divide that in 4, which means in this particular case, I need to look at 0 to pi cut into fourths. So let's think about that. Half of pi over 2, well, that's going to be pi over 4, which means that's 2 pi over 4, which means this is 3 pi over 4. And then we cut these in half as well, so that's going to be 5 pi. Oh, I guess that's just all the over 4s, isn't it? 7 pi over 4. So we're going to have a lot more going on here. So let's give this a shot. Okay, so let's think about what's happening here with our values. So cosine still starts at 0, 0, 1, but this one's been stretched by 2. So we're going to start it up here at 2. And then normally what he does next is he hits 0. Then he hits the lower part, 0 again, then back to that highest altitude. So remember, this is what that period shift does. It means that we complete a full shape of cosine by pi in this case. And then we have to keep doing this all the way through 2 pi. So it's going to repeat itself, go to 0, negative 2, 0, back to positive 2. That's it. So this is the scariest part, and you don't really need to know that much about that for calculus. You'll just be able to recognize these forms once we practice them a little bit more. But I want to show you how the graphs become what they are. So now let's think about our coordinate points. So this one's at a height of 2 at 0. This one is going to be at a height of 0 at pi over 4. Then we got negative 2 at pi over 2. Back to 0 at 3 pi over 4. Back to 2 at pi. You know what? I'm just going to write the rest. Okay, so this means we have way more points to plot. Also, since we added in these new particular, partitions, we're going to have to add those over here as well. So pi over 4s luckily aren't too bad, but I'm going to draw in my 2 diagonals for pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And now let's figure out how on earth we're going to graph this. So at 0, we're at a radius of 2. Easy enough. Then in this first section here, we're going from 2 back to 0. So that we're kind of thinking of these as pie slices now instead of like whole quadrants, right? That's how I see it anyways. So in this first pie slice, I'm going from 2 all the way to 0. Easy enough. It's this one that's interesting. So in this next section, we're looking at this pie slice right here, right? And I'm looking in this section here of my graph. It's going from 0 to negative 2. Okay, well, I'm at 0. Got that, right? But to go to negative 2 means I'm actually going to be moving through the pie slice diagonally across from it. So I go ahead and put my destination point, which again is negative 2 at pi over 2, which means I end up down here. And I know I need to move from the pie slice that is diagonal from the one that it originally would have gone through had it not been negative. Now we'll look at the next section. Again, traveling through negative territory here. And we're going to end up at 0 when we get to 3 pi over 4. And we're again thinking, okay, this is the slice we would travel through, but since it's negative, we're going to travel through the one that's actually diagonal from it to get back to 0. And as you can see, we've completed our first petal. And so we're going to keep going from there. So our next point is at 2 comma pi. So I'm going to end up out here. And this one's positive, which means I'll actually travel through the pi slice I'm at right now. Then my next point is at 0 for 5 pi over 4. So I'm going to use this pi slice to travel back to 0. Got my second petal. All right, now we're at this section, so we're getting into the negatives again. So I would, right, we just finished this off. I would, in theory, be looking in this slice. As you can see, we already have something there, and also we're traveling through negative territory. So we're really going to be traveling through this slice to end up at -2 for 3 pi over 2. So this is where I'm headed. I'm going through the negative. Oh, a little overambitious there. Heading through the negatives. And then we're coming out of the negatives here. So we're traveling through negative area instead of working here to get to 7 pi over 4 in its own area. We're working across from it to get back to 0. And you're seeing where we're going with this. Through this last section from 7 pi over 4 to 2 pi, we're just going to stay in that region and travel back to 0. Awesome! And you have now drawn your first rose. Okay, so that's what these are called. I can't draw the actual rose flowers, so I'm just going to write it. And there's more than one type. It actually has something different occur when there's an odd number in here versus even. And you'll explore how this number is related to the petals as well as this one in class tomorrow.